Okay, so welcome to Tuesday's lesson. Bit of a longer video today because I want to go through the starters that you did yesterday. So great for those of you that had a go at those. So just want to go through those. I want to do a little lesson on the volume of prisms. So I want to talk you through that. And then we'll have a look at today's questions because I'll have to draw those as well. This will also set you up for tomorrow because tomorrow's lesson, not tomorrow actually, on Thursday and Friday you're just doing area and volume of prisms as well, okay, to get you lots of practice with those. Okay, so let's just have a look at Monday's starters. Oh yeah, that's it. Do you remember those with the picture of the Van Gogh Starry Night, or my version of it? Brilliant. Okay, we've got A2 and B3. Sorry, I got a pen lid in my mouth. So right, let's go through these then. So remember so A is 2 and B is 3, and you've got to work out the value of this, 3A plus 4B all over 6. Well, the all over 6 means divide by 6. So this means 3 lots of 2. 3A means 3 times A. So an A is 2, so that means 3 times 2. And B is 3, so that means 4B is 4 times 3. Times 3. So here on top we've got 3 times 2, which is 6. Plus 4 times 3, which is 12, all divided by 6. 6 add 12 is 18, divided by the 6, so 18 divided by 6 gives you 3. So the top row would give you 18, 3 2s plus 4 3s, just substituting 3 in, and knowing that when you get two things put together, it means times, it does not mean add. The add, if it means add, you see the add, and that's in the middle. Okay. Find 90% of 40. Well, you saw my little hint actually. You can do it from 10%. And if you do 10% of 40 is 4, isn't it? Just easy. And then, of course, 90% is 100% minus 10%. And 100% means the whole thing, doesn't it? Okay, and the whole thing, the original thing was £40. So if we start off with the 100%, that's what represents 100%, and we take off 10%, well, 10% is £4. We just worked that out. So 40 take away 4 is £36, and that represents, of course, 90%. An easier way of doing it. You can times 10% by 9. 4 times 9 is 36, but that's an easier way of doing it. Okay, strange one, this one, isn't it? I always say, what's it going up in? And it's going up in, it seems nonsense, doesn't it? It is a little bit. It's going up in minus 3s. That's how we find the nth term. We look at what the difference is, and the difference is minus 3. So it starts minus 3n, and then we look for the number that would exist there. Okay, if there was one. There isn't one, but if there was, what would it be? And it would be 21. So it's minus 3n plus 21. You can, and mathematicians do tend to write it that way round. Write the minus 3n after the 21. It's neater. Okay. Adding fractions, can't do it unless you've got common denominators, and of course you're good at these. We're going to times that by 8, change it into 24ths, and top by 8, and times by 3, and times top by 3, and 16 add 3 is 19 over 24. Divide is divide, so that's KFC. Okay, so keep, flip, and change divide to times. And we get 16 over 3, we just times across, no common denominators. 16 thirds will do me, but how many times does 3 go? It goes 5 times, so it'll give you 5 whole ones and 1 left over, so it's 5 1/3 if you want. Okay, so those were the starters from yesterday. Those are your basic skills, bit of substitution in algebra, percentages, nth term back to sequences in algebra, and then your fractions, adding fractions, and dividing, the two different methods that we have. Okay. Right, volume of prisms. Now, a little bit more to it. I've told you that the formula, for a cuboid is length times width times depth. But a cuboid, you're going to get excited now when you see what I've got here. Some of these here. Let's get some of these shapes out. Then that one will do. Get that one out, and that one out as well. Oh, so I'm getting so excited now seeing all these. Right, okay. So I've got my box of shapes here, and I'm going to create two sort of piles. There we go. There's all my solid shapes. Okay, now these ones are your prisms. Now a prism, not the place for naughty shapes, like our cuboid, they have this front face. You can see on that one, you might be able to see where I've actually drawn faces on some of these. Look, there you go. See when I've been explaining it. Probably to you lot actually. So a prism is when you have a front face like that, and then it's the same thickness going all the way through, like this pentagonal prism. So it has that pentagon, but if I was to slice it anywhere along its length there, okay, it would be the cross section would be a pentagon because it runs right the way through. And that's what a prism is. So our cuboid is actually a square based prism or a rectangular based prism. It's an unusual prism, this one, because any of the faces it runs through the same, see. Okay, whereas the others it's only one of the faces. But that's what makes a prism a prism. This is an octagonal prism. Okay, it's an octagon and it runs all the way through, you can see there. Okay, this one you may have seen in Allen keys, you know, you might have used one yourself or seen your parents putting IKEA furniture together. Okay, and it has that hexagonal cross section that runs all the way through it. This one you'll know it as a cylinder. Okay, and it is a cylinder like a tin of beans, but we can call this a circular based prism because it's a circular base, and it's a prism because it has that circle running all the way through it, like a salami meat. You can slice it and you have the circle of salami right the way through it. And of course the classic triangular prism, like a Boy Scout or Girl Scout, do they have Girl Scouts? Girl Guides tent. Okay, you've got a triangle, and this to me looks like an equilateral triangle, but it runs all the way through it, the classic sort of tent shape. So those are your prisms, and there's a way of finding the volume of prisms. I'm going to talk about that in a second. The ones that we're not going to look at, they're not on foundation, are these shapes here. These are, you can see they have a flat base and they don't, no side runs through it. These are the pyramids. Okay, that's a triangular based pyramid, and this one is a cone, but it's also can be called a circular based pyramid. It has a flat circular base that slopes to a point. The famous pyramids, the Great Pyramids in Egypt, in Giza, they are the square based pyramids. I don't think I've got one of those in the box actually. No, they must be in the other box. Okay, so I haven't got one of those to show you. Okay, so we're not going to deal with the pyramids, but we're just going to deal with the prisms. And what we've been doing is, when we've been doing a rectangular prism, we've been doing the length times the width times the depth. Well, when we do the length times the width, let's put some dimensions on this one. This was one that we did yesterday actually in the lesson, 3 times 2 times 10. The length and the width, okay, well, length times width is the area of a rectangle, isn't it? And that's the area, in this case, if this was this cuboid, of the front face. And then we times it by how far it goes back, the depth. And actually, although you've got this formula for a cuboid that's specific for a cuboid, this system, not the formula, but the system works for all prisms. The volume of a prism is the area of the front face, area of the face, there you go, I've drawn a little face, times the depth. That is the formula for all prisms. So for this one, that's why it works, because when you do length times width, you find the length times width, that first two numbers you multiply together, gives you the area of the rectangle, and then you times it by how far it goes back. So that's why it works, okay? But you can do that for all of the shapes. So for this prism here, the front face is a triangle. There it is, there's the front face, it's a triangle. And we find the area of this front face by going the base times the height divided by 2, because it's base times height divided by 2. That's how you find the area of a triangle. And then we times it by how far it goes back. So the volume of a triangular prism would be base times height divided by 2. We just substitute the length times width, the formula bit for the area of the front face, each time depending on the shape that we've got, and we times it by the depth. So we do base times height divided by 2 and then times it by that distance there, and it would give us the volume. For this one we would do pi r squared. Okay, so we do pi r squared to find the area of that circle, and then if we times it by the depth, okay, the volume of that would be pi r squared, the area of the front face times the depth, and we've got the volume of, you know, how much water that would hold. Okay, if we drilled a little hole and filled it full of water, that's what volume is. Okay, so I think you should understand that, but you certainly will when we do a few questions, because you're clever kids. Just stack those up. Okay, let's have a look at the questions today then. Okay, they are, wow, oh my word, look at that, quality. Okay, I drew that. Okay, SpongeBob. So yes, it's, you know it as a cube, but it's a square prism. It is a cube. Okay, so we're just going to go length times width times depth, and the dashes tell you that it's all the same. So A, the volume is going to be length times width times the depth. It's also 3, and 3 times 3 times 3. 3 3s are 9, 9 3s are 27 centimeters cubed. That's the first one. This one here, I haven't put all the dimensions on, but I've used the dashes system. You've got to know that. You'll see them used on the exam. Okay, so the dash there tells you that the depth and the height, this width of this rectangle here, is 2. So this one is 5 times 2 times 2, the volume of it. Okay, I should be doing this in red, shouldn't I? In a different colour. Let's change colour. Alright, so we've got the volume is 5 times 2 is 10, times 2 is 20 centimetres cubed. Okay, 5 times 2 would give you the area of the front face, and it goes back 2 as well. Okay, C is, move that out, it's over here on the sheet, and I'm going to draw it here. It's this sort of shape. So it's still a cuboid. This is C, and it's 6 by 1 by 3. So it's length times width. The front face is 6 times 1, isn't it? Length times width, and times the depth, it goes back 3. 6 times 1 times 3 is 18 centimeters cubed. And there it is, the first one. So this triangular prism, you've got the, say, the Girl Guide tent, or the Boy Scouts tent, 3 and 5 centimeters. Okay, so this is D. Now this time, we're going to do the same thing, but that front face is a triangle, isn't it? So we can't use length times width. We're not just going to go 5 times 3 times 4. We've got to be respectful that this is a triangle and not a rectangle. We're not daft, are we? We don't just multiply numbers together without any thinking. Okay, so we're going to do base times height divided by 2, and then times it by the depth, which is going to be 4. And the base times height is 5 times 3 divided by 2, isn't it? Okay, 15. 15 divided by 2 is 7.5. 7.5 times 4, okay, is 30. So it's 30 centimeters cubed. Okay. All right. So there we go. Those are the 4 questions. There was a challenge question. It asks, can you find the total surface area of A? Well, actually, I've got a cube. Okay, there it is. There's a cube, a bit bigger than that one, right? But imagine that those sides are all 3 centimeters. Now, how many it says the total surface area, not the volume, the total surface area. So that's your challenge, to find the total surface area of that. And it's like if I was to wrap that up in Christmas paper, you know, so it's covered in Christmas paper, and then I unfolded it, that would be the area of the paper that completely covers this. That's what the total surface area is. Okay, but we can do it without wrapping it up. We look at one of the faces. One of the faces here Okay, you know, if it's this cube, it's 3 centimetres, isn't it, by 3 centimetres. There it is. So 3 times 3 is 9 centimetres squared. That's the area of that face. It's not a volume. It's just that face if it was two-dimensional. Okay, so it has a square of 9 centimetres squared. But actually, it's got another one there, and another one there, and another one there. That's 9 centimetres squared, and another one there, and another one there. And on a dice there are 6 numbers, so there's 6 faces. So there's 6 faces on this cube as well. So it's got 6 lots of 9. So the total surface area is 6 times 9 centimetres squared. 6 9s are 54 centimetres squared. It's the total area that covers this cube. Okay, there we go. So we've done the starters from yesterday. Gives me a chance to show off Bang Off again. Went through those at the start. You've had a lesson on prisms. Okay, they were all my prisms. I did mention our friends the pyramids as well, and been inside the big pyramid in Egypt, the big one in Giza. Okay, and then we did the questions for today, and of course we admired the art of SpongeBob. Okay, there we go. And we did a challenge question as well, total surface area, so we went back and looked at area. Remember, don't get the two mixed up, you know, that's important. Flat area and the solidness of something is the volume, isn't it? Imagine filling something up with water or soil or sand or something. That's the volume, something, you know, how much something holds. Okay, so a bit of a longer lesson today, but you know, I've got a lovely voice and I know that you have probably nodded off now. Okay, but missing you a lot, and hopefully see you in school soon. Okay, guys.